So let's get started. Wow, it's really a lot of people in here, so thanks for coming all, and thanks for having me. Today I want to present to you PDF.JS. One of you have, or let's see, how many of you heard of the project already? Okay, not that much, so there's going to be more to introduce. That's cool. So here's what I want to do, a little bit of overview. And I got a 50-minute talk, and I want to give you something like background on how PDFs are structured, how we process them internally in PDF.JS, and then go to some of the hacks we do to get images and fonts working, and then face the thing or show the problems we face and some steps we want to do in the future, and then to do a small demo at the end. So what is PDF.JS all about? Well, it's nothing else than just building an awesome PDF viewer in your web browser. And it's just using HTML5 technologies. So this really is an experimenting where can you push the web platform, where people will say, well, PDF render, can you do this on the web? Is it fast enough? And this is just a project to see, well, actually we can. We don't use native code. If you want to see how far we come, this here is a keynote presentation export to PDF and brought to you by PDF.JS. So we already got something working, but there's stuff to do. So one of the reasons besides being cool and having all running in your browser is also security. So if you think of it, a lot of people download PDFs nowadays from the internet and just open them in their Acrobat reader. So for some of those, you might think you're secure and what you get back from the server, you can just open, but you never can trust, and even SSL can be attacked, as we know now. So if you just run everything in this really smart sandbox in your browser, nothing can attach or attack your OS system. So there was this article on Heisen News, and also I got this just before. So this is a chart how Windows get affected, which are the main programs. And you see most of 32% get attacked by Acrobat Reader. So if they got not up-to-date version or whatever. So you see this is really something important. And by using just web technologies, you just have JavaScript and nothing can explore. Okay, so now let's go a little bit more in details. So how is PDF structured? To give you a background to see later on how we process it. Well, at the top, we got a header, which is mostly just the version of the PDF. There are multiple versions. Then the biggest chunk is the body. The body is something like a sequence of objects. An object in PDF semantic could be anything, like it can contain fonts that are embedded in PDF. It can contain drawing commands like draw a line here and then rectangle there, or add some text to this and that position. Image data, words, bookmarks, font fields, any kind of information. More at the bottom, we got something like a mapping between objects IDs and bytes offset. And as you see, we got something to do because some font encoding is not working right now in PDF.JS. So this allows you to say, okay, I want to have object number 12. And if you don't have this reference, you would have to go through the entire PDF stream and figure out where object number 12 starts. But with this X reference table, you can say, okay, object number 12 starts at offset 200. So I just got to seek until 200 and read from there. As you know how long an object is, you really can just make sure you read just only this one object. At the bottom, you got the trailer, which contains the root object ID, which is the root object holds all the pages, such that, okay, I go to this object, and this object holds all the IDs to the next object that I got to read if I want to go to page 5 or something. And the cool thing about the structure is you can create PDFs in one fly, because all the jump tables, etc., is at the end. And you can jump around in PDF documents. So if you just got an object ID, you just can go to any offset and read from there. So now see how this works in PDF.JS. So at first point, you make an XHR2 request to get some data. XHR2 compared to XHR is something the same, but you can say, I want to have typed array back. So what you get back is really just a big chunk of bytes array that you can process over. And we build a stream on that. All the streams, encoding, and stuff is all handled in JavaScript. Then we create a new PDF document around the stream, and we read the X reference table, such that we know where each object is is pointed in the data stream, and we read the root object. And then we say, well, we want to have page n. Okay, we get page n. And then we say, well, we want to start rendering, and we pass in graphics object. And the graphics object is what later on knows how to deal with the painting commands that we send to it. Internally, if you just call start rendering, you read and convert all the PDF commands that are in there. We see that later, and we create an IR form. And that's done in the what we call partial evaluator. And we make sure that all the required objects like fonts and images are loaded, because if you try to set a font on the canvas and you try to render it before it's not loaded, you just get nothing. So you don't want to have that. And then once we are ensured and we have all complete IR, we say, okay, graphic execute our IR, and you get something painted. And currently we have a canvas backend, so that's done by canvas graphics. So let's go even a little bit more deeper. If we say, for example, okay, PDF document, we want to have get page n. Let's say, okay, and it should have be the term. So let's say we want to have the first page. It says, okay, you got to go to object number 3. So this is what object number 3 looks like. Actually, it's really like this if you open a PDF document. Sometimes it's compressed, so you don't see the content in this readable format, but basically it's really just a set of commands. So you see object number 3, it's type of page, we know how big it is, we know where the resources are, that's object number 4, we know the parent, and we know the content is object number 5. So we want to process object number 4 and object number 5 when we want to render. So this is now what object number 5 looks like. We know, okay, so here we know it's the length, 8, and it's a stream. And as I said, stream might be encoded. In this case, it's plain text to be a little bit more easier. And you already see there's some kinds of commands, like, yeah, begin text, move somewhere, show some text, and we're going to see this later. Okay. Now, internally, as I said, we fetched already our resources, and now we got this thing read. We, together with our X-reference catalog, which is this root object thing, and the resource that we load, we bring it to the partial evaluator, which creates our IR form. And this is what the current IR looks like. So you see, most of the commands just get expanded, and PDF puts the name of the commands at the back, and we have them at front, and just the parameters just become more or less arguments that you put to function calls. But we also do some transformations. For example, this one here on the left-hand side in PDF means, okay, set the current font to font 0, which is a reference to the resources, and use font size number 12. Internally, we say, okay, font 0, which is font 0 in our object space. We load it, and once it's loaded, we resolve a promise. And the dependency we add to the IR makes sure we don't come across this point until the font is resolved. So what happens? We say, okay, execute the IR. We go through all the commands, and we say, okay, there's a dependency. We check if the dependency is satisfied. If it isn't satisfied yet, we stall the execution, wait until it's satisfied, and continue the execution again. By doing this, we can later on split up processing of the PDF, because you can think, okay, I got a font that's required, I got an image that's required, so you can send the object for the image to a web worker, which does that thing, and the font to another web worker. And once everything is there, such that I can continue execution, it's going to happen. And this IR form is then passed to Canvas graphics, which do the actual rendering. Okay, So this was more or less the technical stuff. Was that too hard, or are there questions raising? Internal representation. So if you just, the problem is in this form, if you just take this, you got still reference to objects. And the idea is that the IR don't have dependencies on any streams of things anymore, such that if you move some chunk of data to a worker and it sends something back that's in an IR form, you don't have to get access to data anymore. So that's why I make transformation also to add in the dependency stuff. And there's the PDF document can also have something like nested PDF documents where it says, okay, this is here is a formula again, and you got to go to another object and just do the processing as well. And we flat that so that we just add it with one IR stream. Okay. Other questions? Okay. So now two technical things I want to cover a little bit more in details. So how do you load images to render them in a browser? Well, so in PDF documents, there are two different kinds. You can have a JPEG stream. Well, that's quite simple. You just read some bytes, you convert them, and then you create a DOM object, and you set the source to data URL. And once it's loaded, you say, okay, I can use it. Well, if it's not JPEG stream, there can be different color spaces in PDF, etc. And sometimes it's just like you've got some byte and then you got, okay, this is grayscale, but I got to have 4 colors, alpha, red, blue, green, green? Okay. So we got to make this conversion ourselves. So what we do, we read the bytes, we convert them to the color space, we take some image data of the right size from a scratch canvas, we fill the pixel data on the canvas, then we put the image data on the canvas again, and we draw the entire canvas on our PDF canvas. So you see, this is really a lot of work, but it still performs quite well. So next things are fonts. There are two ways you could handle fonts. One is rendering each character with drawing commands. So if you got an A and you have something like this, you draw one line here and one line here. Or the other option is transforming fonts. And there are a lot of different fonts, and as you see, fonts are still not really supported at all edges, and there's some formats that we don't support at all. The way we do it is we take the PDF fonts that are embedded and convert it into open type fonts. Then again, we use CSS to attach them to the DOM, and once it's loaded, we start rendering. Because if you say I want to use a font and it's not loaded yet, you might end up with white space. There's a problem that some fonts cannot convert it to open types, or at least not that simple, and we don't know yet really what we want to do there. So maybe these fonts got to be drawn really one by each other. Okay, so now let's face some problems that we have. In the following, I'm going to use platform for browser plus OS combination. So there's actually no real way to detect if a font is loaded. There are things like, okay, we can see if the width of something changes or if there's some output, but there are really edge cases where you just have a white, just a space. So if you want to say, well, if there's something drawn, then I'm loaded, but if you have a white space, you don't see anything drawn. And also there are some edge cases with width. So we got something hacked, like we load curl the font in iframe, and if the iframe says I'm loaded, we hope that the mainframe has the font loaded as well and say it's loaded. But that's not working on WebKit in some situations. Font width, so some fonts report a different size than it actually should be. So if you render it in Firefox on some platforms, it ends up positioning them at the wrong place. So currently we got to paint every character on its on the calculated position to make sure it get right. Subfont subpixel font size is not working on some platforms. That's also why we draw each character on our own. Text selection is not working because we just use canvas. So we got some text, but yeah, we can't reselect it. Printing is also a problem because currently we just draw canvas, and if you say, okay, just have print, and you remove some of the UI of your PDF, you end up with this low rusted canvas thing that you send to your printer, which is, if you expect at least 100 dp, way too low. So there are two ways. Either we create a really giant canvas, or we might want to use SVG. Sure, speed got to be better, and we want to achieve this by using workers. I did some work on this direction, but it's not landed yet. And also, we could maybe do something like partial rendering, where you say, okay, I got this part of the document ready, I just start rendering, and there's maybe a subformula that isn't already, or nothing, not everything to render is there at this point, but maybe if most of the text is there and just a little bit is missing, it's better than just holding on till everything is there. So here's the list of to-dos that came up. So as you see, there's more font work. We got to figure out printing speed. We got to support more of the rendering spec. So what we have actually allows us to cover a lot of PDF documents, but there are a lot of edge cases, like you can have PostScript embedded as some functions in PDF and some weird shading, and they all got to get implemented. Also, we might want to explore SVG. How slow is it? How fast is it? If we get SVG working, we get around text selection, because we have text there that we can select, and also printing. There's a bug on Mozilla that you can't select SVG right now, but people are working on it, they said. Then there are more advanced features than just rendering. So you can have PDF formulas or 3D graphic and crazy stuff. PDF forms is something you might look in the future, and the more advanced stuff got to see how it fits. Also from an infrastructure point, someone that's got hired from Mozilla is working on automated testing environments, such that you can say PDF.JS bot, please start testing, and it makes a pull from pull request and checks all PDFs that we got and make reference tests and see if something changed or not. And also currently the entire code base is more or less all JavaScript style, so everything just goes to global space. So we might want to have something like Wire.js to clean that up. And also we want to test more PDF documents, because it's hard to implement specs if you don't have a test object. So if you want to help in a very simple way without contributing code, please open 1 or 2 PDF documents that you come across, or even more, and if something breaks, follow a GitHub issue. Okay, so demo time. Any questions so far? Yeah.
For the testing PDFs,
yes.
it would be nice to have a public repository of edge case PDFs.
Yes, so what we do, currently we got some URLs of PDFs on the web we just pull in. And basically each time someone comes up with a problem, we ask him politely if he can put it somewhere that we can pull in. Or if the copyright is okay, we just move it to the repo.
How you're managing it? It's public after the release, or?
Yes, so it's all on GitHub.
Because we have another project which has the same problem.
Mm-hmm.
Thinking about how to collect PDFs.
Yes, there was also the idea at a Mozilla All Hands In meeting that we could use Bing search and say, well, give us the 100 or 1,000 most popular PDF pages. Hope that copyright is okay with that. Pull that in the repo and see if that works. So, some kind of that. Yes?
Have you already solved the problem with searching on it? I guess if you render the fonts yourself, then you don't get the text content where you can search and locate the position of the.
So, search isn't working right now. Well, I mean, we know where we rendered the text, so we could keep that in mind. Something. It's not working right now, so definitely a feature to implement. But what we have is links, such that if you hover over some text and click on it, it goes to another page. That's working already. Okay. Otherwise, I go to demos. So this one here is what I'll start with. So for some reason it doesn't take up the right size. Sorry. So this is the first document we had. So TraceMonkey paper. Andreas Gall started this project and he implemented TraceMonkey for Mozilla for Firefox. So that's why he chose this document. And there are some graphics in there. You see, there's quite some stuff already working, but you see it's kind of lagging. Whenever it's reaching a new page, the whole UI freezes and stuff. That's because everything is single-threaded right now. So especially here, takes quite some time. So yeah, so we hope we get that better with if we use Worker. Also, if you got really giant PDF. No. Sorry. So, for example, if you take the PDF, well, it's documentation that's available by Adobe, and that's 32 megabyte, and you can think if you got to render all over this, it's going to take some time. Yes, we want to continue. But once it's there, yes. And the first time the font is loaded, because font loading is really going over all the bits, making sure they're open typed and stuff. Now you see here, we can jump here, and we just jump to the place in document. And if the page is more or less just text, the speed is already quite useful. But yeah, they're rendering bugs. So,
How much memory is used in program?
a lot. So, as I said, the cool thing is, in theory, you would just store the data and then read some parts of the object. And what you also could do is say, well, server, maybe you'd be polite, and if I just want to have this range of data, you just send it to me. So saying the server supports that, you can't do right now, but there is a draft to make XHR just say I want this range of bytes, and that way you can prevent dialing 32 megabytes maybe, but that's not working right now. Yes. Sorry? So, maybe I repeat the question. So the question was if you can use HTML and CSS just for text rendering and stuff. If you think of it, there's something like SlideShare, is it called like that? And Crocodoc, which allows you uploading more or less your PDF slides and they convert it to HTML. So it's possible to do that. We got to explore how fast that is. And there's some, so the problem there is what can happen in PDF is you got some text and you got some graphics above and then some text again. But you don't know how big this graphic is going to be. So you would need to spin a canvas for the entire document again. And what can happen? You have a little bit of text and giant canvas again, a little bit of text, giant canvas. So you would use a lot of memory stacking all this canvas above. And I think the PDF renderer on the web that converts to text and CSS, they just say all graphics go to the background and we put text on top. So if you have some graphics that cover the text, it won't work because it just puts it down. We want to have it really working, so get to see. Yeah.
What's the size of the file?
So I think the main PDF file, PDF.JS file is around 300K and other stuff without compression. So it's quite huge. If we got to implement all this different streams, and yeah, there's a little bit of code. Okay, yeah. But we haven't, yeah, we don't get that much working as they do, but yeah.
Pretty sweet. Can you give a short introduction about you or your group or what?
Oh, yes, sir. So I'm actually a student at ETH, studying physics, and I was at Mozilla 2 weeks ago, hacking on PDF.JS. So where I met Andreas and the rest of the team. And currently things are like, Andreas is making some code reviews and got some good input, but he's working on BoottoGecko right now. Chris Jones, who was at the first time with with Andreas working on this, is on BoottoGecko as well. There are now 2 full employees working for Mozilla on the project, one on test infrastructure, one other guy implemented PDF renderer as well, and so he hired a competitor. And there is one contractor and a few contributors, so quite a few shades. And maybe that's a good part. So I got your other contacts, so GitHub page, my links, and IRC if you got any questions, if you have PDF that's not working. And I hope you get, so there's a getting started thing that there's an online demo that you can check out. So if you just want to test if things break or not, that's the easiest way to go. And there's also how you can clone stuff and make a server running. Okay? So thanks for listening and have a good one.